All right, good morning, everybody. Afternoon, whenever you're watching this video. I'm gonna do the solutions for this worksheet. All right, Newton's three laws. 1, 2, 3. Second law is easiest. F equals ma. First law is object in motion will stay in motion unless acted upon. That's good enough for me for right now. The third law is every action equal opposite reaction. Good. That's good enough for me. You guys should know this. You can look this up online. Write this down in your notes if you're going to be in class during the test, which is next Friday. All right. So what force is being applied to a 5 kilogram object moving at 3.8 meters per second? F equals ma. F equals 5 times 3.8. F equals... Oops. (19 newtons). What is the mass of an object being pushed by 23 newtons at 4.6 meters per second? I'm just going to rearrange this already. Mass is equal to force over acceleration. M is equal to 23 over 4.6. 3 divided by 4.6. Oh, look at that. 5 newtons. Acceleration of an object being pushed by 15 newtons and has a mass of... So let's go F over M is equal to A. 15 over 8 is equal to... Let's do it like this. 15 over 8, and we get an acceleration of 1.88 meters per second squared. What's the formula for weight? W equals mg, mass times gravity. What's the formula for normal force? Fn equals mg. Same thing. What is the mass, or what is the weight of a 16 kilogram object? Weight is equal to 16 times 9.8. It's equal to 156.8 newtons. What is the weight of a 33 gram object? Weight equals mass. Let's find our mass. Let's do 33 divided by 1,000. Since it's 33 grams. Oh, whoops. Since it's 33 grams and not 33 kilograms, we have to divide it by 1,000. So whenever the problem's given to you in grams, you automatically just divide that by 1,000. Right? 1,000 grams equals 1 kg. So if an answer is in 33 grams, it's equal to 0.003 kilograms. 33. And, well, this calculator just broke, so I'll be back with another one. I'm back. Let's go. So, 33 divided by 1,000. 0.033 kilograms. Okay, so 0.033 times 9.8 gives us a weight of 0.32 newtons. What is the normal force of a 16 kilogram object sitting on a table? Already figured that out. 156.8 newtons. Why is weight and normal force the same? Equal and opposite forces. A 1.23 kilogram block sits on a table. There's a forward force of 2.28 newtons and a force backwards of 0.53 newtons. What is the acceleration of the block include the direction? Well, automatically we know that this block is going to move to the right because the net force is larger to the right. So our net force is equal to 2.28 minus 0.53. 2.28 minus 0.53. That's equal to 1.75 newtons going that way. So then let's set that equal to 1.75 newtons, and we're going to divide it by our mass, 0.32 kilograms, to get our acceleration, right? F equals ma. I divided the m over right here. Okay, so let's do that. Divided by 1.32. Our acceleration is equal to 1.33 meters per second to the right. I want to check that and make sure, because that's strangely divided by 1.32. Yeah, that's weird. That gives us 1.32. That's weird. All right, last question. Your car is initially at rest when you hit the gas and the car begins to accelerate. The forward force on the car is 5,710 newtons, while the resisting force is total 410. Let's go ahead and find our net force then. So F is equal to 5,710 minus 410, which is equal to 5,300 newtons. Car has a mass of 1,091 kilograms, and the acceleration lasts for 4.8 seconds. Interesting. All right, so let's go ahead. There's a lot going on here, so let's go ahead and write this down outside the problem because it's really wordy, and we want to keep ourselves organized. So time also equals 4.8 seconds. What is A, the acceleration of the car? Easy. We can find that because we know F equals ma. So we know force, we know mass. So let's do 5,300 over 1,091 equals acceleration. Our acceleration is then going to equal 4.86 meters per second. Final speed of the car. Okay, we have an acceleration for 4.86 seconds, or 4.86 meters per second squared. We have a time of 4.8 seconds. We know this equation right here, A equals delta V over delta T. We know our initial velocity is 0, so we can just write it as this. A equals V over T. So to get our V, we just multiply the A by the T, right? We just multiply this over here, and I'm just going to swap it and say V is equal to AT, velocity is equal to 4.86 times 4.8. Multiply that by 4.8. And we get a final velocity, VF, of 23.32 meters per second. All right, 23.32 meters per second. How much ground does it cover in this time? Well, we have